Assalamualaikum. My name is Siti Safawati binti Zamri. I'm from EH2435B Group Dynamics. So today I would like to explain more about multi-phase flow metering on its application, performance specification, field installation and also consideration when designing MFM.
Assalamualaikum warahmatullahi wabarakatuh. My name is Karinisa binti Zulkifli. I'm from Group Dynamics and I'm from EH2435B. So today I would like to present about multi-phase flow meter. I will talk about the definition of multi-phase flow meter, the multi-phase flow and meter categories.
My name is Muhammad Razi bin Rosla and from Group 1 Dynamic, we are given a task about MFM, which are multi-phase flow meter. Okay, I am from Group EH2435B and going to explain about the principle, the technology.
So, what is multi-phase flow meter? Multi-phase flow meter, or known as MFM, is a measuring tool that is functioning to identify the phase flow rates of constituent phase individually in oil and gas for a given flow, where initially oil, water and gas are intermixed together during the production of oil process. Multi-phase flow has complicated flow compared to single phase because in a single phase we only can see the lamina and turbulent, but in multi-phase it is affected by the orientation of pipe and superficial gas velocity. As in the slide, the figures show when the orientation of pipe is horizontal, the flow involved in this phase is plug, slug, bubble, stratified, annular, mist and wave. Meanwhile, when the orientation of pipe is vertical, the flow involved is bubble, dispersed bubble, slug, chine and annular. So now I'm going to talk about the meter categories. The following meter categories can be applied to MFMs, such as inline meters, separation type meters, wet gas flow meters and other categories. For inline meters, all measurement of phase are performed directly to multi-phase flow meter, so there is no separation of fluid is required. For separation type meters, this meter consists of two parts, which is partial and complete separation of multi-phase stream. So for partial, this meter only separates gas pipe instead of full separation in complete separation. So for wet gas flow meter, this meter can be installed as a standalone system in a typical wet gas application, or it can be installed in conjunction with partial separation system. Last but not least, for other categories, it is included advanced signal processing system, or it is called visual measurement system or VMS. It is estimating the phase variation and flow rate from analysis of time variant signal from whatever sensor available in the flow line, such as the sensor might be acoustic, pressure or other types.
Okay, by now you must be familiar with the term of multi-phase flow meter or MFM. So I'm going to explain the technology of MFM. Okay, multi-phase flow meter are invented to act as alternative for conventional test separator. MFM are capable to perform continuous monitoring of production rate at the reservoir. Technologies such as gamma ray, magnetic resonance or non-reactive technology are commonly used in the industry. However, the usage of radiative materials such as gamma ray have higher efficiency and performance compared to other technologies. Non-radiative technology are still in use in order to maintain the welfare and the health of the workers at the industry. Next on my list is I'm going to explain the principle of three common technology used in the industry, which are magnetic resonance, gamma ray and non-radioactive. First on my list for the principal section is magnetic resonance. First of all, what is magnetic resonance? Magnetic resonance is the occurrence of electromagnetic radiation that will be absorbed by nucleus. Next one is the flow will be exposed to specific radiation, frequency, and form magnetic field. By referring the picture, it shows that the flow is exposed to pre-magnetization and then into measurement section for the data that is useful in order to increase the production performance. Okay, so next I'm going to explain about gamma ray technology. Gamma ray technology is commonly used in the oil and gas industry. Why? Why is gamma ray popular in the oil and gas industry? The answer is gamma ray technology have the capabilities to withstand challenges such as slugging and at the same time provide good readable data of composition in the reservoir. Common radioactive materials such as barium-133, americium-241 and caesium-173 are used in the technology. The stated materials are used by making them pass through the pipeline and then determine the composition in the pipe. However, everything comes with a price. Gamma ray technology proved to be poisonous or can potentially bring harmful effect to those who work near the equipment. Last but not least, the non-radioactive technology. Based on the picture, I'm taking orifice plate as one of the examples that are considered the non-radioactive technology because there is no involvement of radioactive material in the pipeline. Okay, how orifice plate works? Okay, we install a orifice plate in the pipe which causes disturbance of flow, and then the differential pressure can be obtained by using Bernoulli's equation. The bright side of using this technology is we can ensure the safety and welfare of our workers and at the same time maintain the shelf life of our existing equipment from corrosive materials such as radioactive materials.
Okay, we go to the application of multi-phase flow meter. For the first one is production system design facilities. The use of MFM can reduce hardware needed on onshore, offshore topside and also offshore subsea application. And the most important things is the removal of dedicated test separator for well testing application. Thus, use of MFM for the topside application can reduce load requirement and also reduce platform space. And for the second one is well testing. As we know, conventional test separator is very expensive and also require much time to monitor each well performance. And for that, time required to restabilize flow condition is also longer than usual. Then disadvantages for using test separator is well performance may suffer after shutdown cycle and also require more frequent workover. Thus, by using MFM, will give more satisfactory measurement and also can monitor well during clean-up flow phases. Okay, for the third point is reservoir management. MFM can provide real-time continuous data to enable operators to characterize field and reservoir performance better and react faster. For example, changes in gas or oil ratio or water cut can be detected and quantified immediately, whereas traditional test separator provide information about only cumulative volume at discrete point in time. And for the last point is allocation of production, which is one of the most common application where information on flow rates from individual well is required is in the allocation of hydrocarbons that have been commingled. The allocation is based on whatever source of information is at hand, and based on this data, the production that has been accumulated over a given period measured at a point of relatively high accuracy and is allocated back to the production facilities and wells from which it was produced. Unfortunately, there is no single instrument that can measure different phases of flow rate, and it is necessary to combine several devices in an instrument to calculate the specific flow rate from combined reading. That's why MFM is widely used or introduced to the offshore and offshore production. As you can see from the figure, this is the example of application of MFM in offshore production and consisting of several neighbor wells. The flow data gathered along a pipeline section of a given well can help in identifying how well this well contribute to aggregate flow and hence may help in locating production anomaly such water or gas breakthrough in the actual well. This also allow localization more easier of well stimulation or EOR to be performed in order to increase the well productivity and also help well engineer to monitor effectively of the propagation of oil from the actual well by adequately controlling the area of the valve in that well. Sometimes manifolds and valve system are eliminated. Given the possibility of continuous metering, the overall uncertainty may be lower than in a conventional system. And for the disadvantages is sampling of the process fluid is not readily available. An inlet separator may be required as a slug catcher and for well cleaning purpose. And multi-phase metering is not traceable to any accepted standard. Next, we will go to the performance specification of multi-phase flow metering. For the first one is uncertainty description. It is a measure of flow element performance, represent the difference between how an ideal flow meter would perform and how the real flow meter actually perform. The preferred performance specification of a multi-phase flow rate meter is given in terms of percentage uncertainty of actual oil, gas and water and also volume flow rates. For the second one is the reproducibility of a meter, which is a quantitative expression of the agreement between the result of measurement of the same value of the same quantity where the individual measurements are made under different defined conditions. One significant difference between multi-phase meter and single-phase meter is the most of the uncertainty of a multi-phase meter is caused by variation of process condition and fluid properties rather than uncertainty of the primary measurement element. And the last point is influence quantities. Influence quantities are to be understood as quantities that alter the specified accuracy of the measurement. It is important to specify what is influenced by the quantity in question and, if possible, to quantify the effect of the uncertainty of the measurement. Okay, we go to the next topic, which is field installation of MFM. Most, but not MFM are installed vertically because the flow pattern has a significant bearing on the MFM readings. There are 7 horizontal flow patterns and only 5 vertical patterns. Therefore, installing the meter vertically automatically reduce the possibilities. In the vertical flow, bubbles and slug are more evenly distributed across the pipe, unlike the horizontal flow where slugs and bubbles, due to gravity, they tend to migrate at the top of the pipe. For your information, there are 3 criteria that need to be considered before installing multi-phase flow metering, and the first one is selection of installation point. Measurement of MFM usually based on condition of flowing fluid. This measurement needs to be calculated back to measurement at standard condition to reduce uncertainty if non-equilibrium fluid is detected due to choke, creating significant pressure drop. And for the second one is flow regime prediction. The flow regime at cross-section of MFM is influenced by flow condition, pipe configuration and orientation. flow condition may be distinct due to composition of velocity at the cross-section, thus affecting accuracy of measurement. And the last one is mixing device, which is static or dynamic utilization. This is important in order to have well mixing flow and encourage flow homogenization. The mixing device used has different specification from conventional to advanced that can reduce slugging problem by absorbing it. Okay, we move to the next section, which is consideration of multi-phase flow metering design. Okay, the first factor is pigging. Usually pigging is take place during maintenance and liquid accumulation removal at low pipe section, which usually creating hydrate formation, corrosion and rising of pressure drop. Thus, to avoid this problem, pig speed is recommended from 6 to 15 feet per second for liquid and 9 to 18 feet per second for gases. And for the second point is hydrate formation. There are three types of hydrate inhibitor that usually used, which is kinetic, thermodynamic, and anti-agglomerant. And noted that different type of inhibitors giving different in production time during dilution in pipelines. Okay, for the third point is deposition of wax and asphaltene. There are a few techniques have been done to reduce this deposition, such as shear reduction, minimize pressure drops, and mix between asphaltic crude with lean feedstock, and continuous chemical injection such as deasphalted oil or aromatic solvent. And the fourth point is slugging. Slugging is caused by oscillation in flow rate caused by slug lead to flooding, also increase due to deposit and rate of corrosion. And how to control this problem is by gas lift, gas injection into the reservoir, and installation of multi-phase pump or separator near to the wells. Okay, for the next point is temperature. Knowing that if the temperature increase, the corrosion of pipeline is also increased. So by using corrosion resistant pipe help to cool down the fluid that will enter into the pipeline and to reduce the rate of corrosion. And for the last point is packing, which is addition of flow stored in pipeline, which will increase the operating pressure, and it is important in order to maintain production during shutdown at facilities.
As a conclusion, MFM play a bigger role in oil and gas industry. Better reservoir exploitation or drainage can be achieved by using MFM because continuous monitoring of well performance can be done. MFM also can be applied in many applications of oil and gas industry, such as production system design facility for well testing, reservoir management, and allocation of production.